Hi, I'm Reg Harbutt, IBM champion for Z mainframes and an active mainframer for over 3 decades. Recently, I had the honor and pleasure to interview some key luminaries in the mainframe ecosystem to get their take on the excellence of the mainframe's journey of innovation. What follows is a compilation of their insights on this compelling subject.
Well, I can say this about the future of the mainframe. It's never been brighter. The things that I know that are being worked on, that I know of through non-disclosure, I can't say, of course, here. It's just, I just don't know when it's going to end. It's just when you think it's, well, how can it get any better? It's going to get better. And it's going to be, there isn't anything that the mainframe can't do.
This is where I think we'll grab a lot of people that say, this thing is powerful. This is running the world. I know, from the outside how to do some, good management things, but now I want to really get down and deep and figure out what's going on internally because this thing's fascinating.
Think about innovations about moving the Z system and ever shrinking the Z system. I mean, the latest machines, single rack machines, thinking about the fact they fit in a standard rack, not, specialized sitting in the corner innovations. If you look at the Z16 and the Telum processor and the idea of putting AI on the chip, the innovation is just amazing in that case. The big bet was to take this wonderful mainframe technology that we had that was very special purposed, very specific models for scientific, for business, for different tasks, and create a general purpose mainframe, a general purpose system. And that's the 360, because we didn't want to have specialized everything for everyone. And so it's all about people. It's about making it simpler for people to interact, whether or not you were in science trying to go to the moon, or you were, well, I guess that's not just science, but you're trying to go to the moon, or we were trying to work on a business problem for a bank. Consistent technology makes it a lot easier to do things.
It was interesting to see as I taught the different evolutions of the different small computer platforms and the operating systems, how much those operating systems ultimately emulated what we already had on the mainframe. If you just think about things like ZVM, carving up a physical resource into logical resources is like mind-blowing for the folks that are off the mainframe going, wow, who could have come up with this? We'd already had it for years. The idea of program isolation, memory isolation.
And now fast forward to today, and now you see all of this stuff going on with Red Hat OpenShift, with containers, another more dense way of virtualizing the system on top of KVM or ZVM hypervisors that are on there now, and further and get more out of their systems because they can run more densely populated applications on the same hardware. In fact, some of these systems now have the ability to run, a couple of million of these containers right on a single Z system, which you could never really do with the alternative platforms that are out there today. And I foresee it not happening ever, them really catching up to that level of density either.
We've got all these great new capabilities coming out on ZOS platform, and this includes the whole stack all the way up, all the way down to the hardware. And these capabilities are so wonderful, and I really want people to start using a lot of these capabilities and just showcase the awesomeness of this platform.
What I say is it's really biz, dev, sec, QA, inf ops, because really what we need to do is break down all the silos. We really need to collaborate across the organization to make sure we're driving the right business value. And if you think back long enough ago, a lot of the COBOL developers were actually business analysts who were implementing business logic in COBOL.
So, Red, did you ever hear of the $30 million blade you could buy for $30 million? You know what it was?
I did not.
What it was, it was going to cost them $30 million to add one more blade into their cluster because they had to add a data center, build another data center for $30 million. That's why it was the $30 million blade. So some of them got smart. You know, they started finally listening to my preaching to them and they wanted to come back and talk to me about this virtualization with Linux servers on this mainframe. Tell me what it really can do. And once they started understanding it better, they started putting in these systems to consolidate these servers. And they were finding that it was saving them a tremendous amount of heat, power, cooling, floor space, software licenses, and very expensive data center expansions. And all along came more and more of these systems. And, now a lot of people have Linux across the world on the IBM mainframe running right alongside of their ZOS or their ZVSEs environments and doing quite well with them. Because, in fact, those that do that to their ZOS and ZVM and ZVSE environments with Linux on the same systems find that they become a stronger hold within their organizations, and a lot of growth occurs.
This platform can drive throughput like none other. And as workloads grow and expand and higher speeds and capacity and throughput are needed, people are investing to advance not only the platform, the hardware, the OS, but the middleware, software, and the applications around it. So while the technology is advanced, it's how the people have applied these technologies to solve business challenges that's what's the most interesting.
We spend a lot of time in development making sure that everything we do is compatible so that that new software can come into the customer shop that much faster to help them stay current. And they spend less time doing upgrades and more time, finding new value, putting new functions in, getting them to work.
Even in and around that time, before RACF, Top Secret, and ACF2 were really prevalent in the market, IBM had its integrity statement. And basically, the integrity statement said that IBM would ensure the integrity of any process. And by that, they meant that any access to memory, storage, or any other application or program that allowed the system to run that was done through a non-allowed access, that IBM would fix. And essentially, in 1973, they put out the IBM integrity statement, basically said, we will ensure the integrity of this system with some moderate exceptions. For example, one of the exceptions is that if you take and allow someone to put in an APF authorized library that has an AC1 linked module in it that can put itself into supervisor state or key zero state, that they couldn't prevent that from violating the integrity of the statement, but violating the integrity of the system. But outside of that, they can. So the integrity statement was key because IBM actually said that they were going to ensure the integrity of the system, and that you have to put that stake in the ground when it comes to security. That security does you no good if there's no integrity in the system itself.
Quantum's going to do lots of things, but it's also got an opportunity to break a lot of security models. And so the idea of quantum safe and bringing quantum safe into the system early so that people can really protect their data. I think as humans, we have too many people who are too open with their data. Privacy matters. I think privacy is important. And I also think controlling data appropriately is important. And the Z has been there to help control your data from a security standpoint, bringing in pervasive encryption and then quantum safe, trying to make sure that we do focus on the people and their data and how to appropriately address that.
So reliability, availability, and serviceability, RAS, right? Those, when people talk about security, they very rarely think about RAS, but it's actually important because if your system's not up and available, security doesn't matter. Beyond that, we're talking about within the system itself, not just the ESMs, but going back to the IBM integrity statement, how important it is that the system itself keeps data and programs separated from in memory and from other programs themselves. So you have integrity of data, you have integrity of programs. It's not easy to write a program to go run on a mainframe, go read and see everything else that's happening in memory, because you're denied access to that, unless, again, you're running an APF authorized, supervisor state, key zero, things like that. But outside of that, all of that is the basis for security. Without it, you couldn't have security. And then, of course, lately, encryption, right? Pervasive encryption, encryption across the entire platform, end-to-end communication.
When I reflect, I think about all the teams that I've worked with in my life. You think about what is unique about the people in the mainframe ecosystem, the passion, the commitment, the investment you see from them in the platform, whether they've been here for many, many years or whether they're newly entering the ecosystem. They see this fraternity, this group of people that are committed to driving things, and it envelops you. You want to be part of it. You want to be doing meaningful things in the world. And then you watch, I think like no other space, the knowledge transfer between tenured experts to the new, fresh people, while allowing for those new, fresh people and perspectives to be fed back into the platform with the right investment is unparalleled, right? So we're doing investments in a vitality program where we're building skills for our customers around the world.
Well, here's where I want to go next is, the way you describe the HBCUs and the engagement with mainframe is so profoundly resonant with the very journey of the mainframe itself. Something of a real, genuine quality that has been ignored and set aside and yet is still there. And what an amazing connection. Maybe because you've gotten to know the mainframe so well, if you can kind of reflect on the journey of the mainframe from the perspective of the mainframe and how it's parallel to the journey of the HBCUs and your students.
Perfect lockstep, and you need a Reg Harbeck to see that. This is not a complete analogy to what you're saying, but it brings to mind most people in America aren't aware that the whole hip hop thing perfectly replicated the emergence of jazz. Perfectly replicated. Poor people, illiterate, outcasts, developed a world-renowned art form. Same thing. Then what you talk about the mainframe with the HBCUs being a match made in heaven, even though I didn't think about it in those terms, I've seen that all along. Now, I'm not taking credit for having your vision. I didn't see it quite that way. The whole synergy between the dynamics of HBCUs and the dynamics of the mainframe community. I didn't conceptualize it that way, but I saw happening. What you say that leads to, that's what I saw happening all along. And I still see it.
Yeah, when we think about what we've been doing on the hardware and the software related is to make it more consumable, more accessible, and to make sure we are addressing sustainability goals. So when I think about human impact, computing technology is everywhere now. Absolutely everywhere. You can't get away from a computer. Software is in everything. And if we think about that, it means that we're spending a lot of electrical power. We've got to take all that into consideration. And so sustainability is key. And we think about the Z, it's had a focus on sustainability, power consumption, how it's handled in the environment for a long time. And when we take that into consideration, instead of having a huge farm of servers, I can put in one nice Z box and I can use a lot less power. So from a human standpoint, from an environmental standpoint, we have that aspect. We also, from a Z standpoint, continue to try and make it more consumable for people. How do we make it more accessible to people so that they can understand how to work with it and how to evolve?